Welcome to Bell Institute classes. Now let us see factorials. What is factorials? Factorials. Factorials is nothing but, let us say you have a number, okay, for a natural number. Okay, we are considering here only the natural numbers. Natural numbers, hope you all know what is natural number, right? 1 onwards, all the numbers, okay? Whole numbers, 1, 2, 3, 4. That is set of natural numbers, okay? For a natural number n, okay, let's consider that number as n. Its factorial is defined as n factorial. Okay, we'll write like this, the exclamatory mark. Okay, so n factorial is equal to 1 into 2 into 3 into 4, and it goes on until n. Okay, this n may be any number, either 10, 20, 40, 100, 1000, whatever. So whatever number you consider, that number factorial is nothing but starting from 1 into 2 into 2, 3 into 4, like that it goes on until the same number whatever you have considered. That is factorial of that number. Okay, let's see an example for that. Now find the value of 4 factorial. This is the given question. Okay, find the value of 4 factorial. What is 4 factorial? 4 factorial is nothing but 4 into 3 into 2 into 1. So how much is that? That's 24. Okay. Now let us see permutations. Okay. Permutations. So what is permutation? You all must have heard about permutations, right? So let us see the definition first and then we'll explain. A permutation is selection. Permutation is nothing but selection and arrangement of objects in a definite order. I'm just underlining this word order. Okay, the order of arrangement here matters a lot. That's very important. Okay, here the order of arrangement is very important. Okay, so do we understand by this? Permutation is nothing but arranging the objects in a particular manner, in a particular order. Okay, let's put it across in another form and then we'll see the explanation. The number of selections and arrangements means to say permutations of R items out of n different items is represented in the form Npr and is given by and it's given by Npr is equal to n factorial divided by n minus r the whole factorial. Okay, n minus r the whole factorial. So this is the formula for finding the permutation of a given particular situation or for the set of numbers. Okay, now let us see an example for permutations. Okay, the question would be, let us say you have three alphabets A, B and C. Okay, these three has to be arranged. Okay, these three has to be arranged. Arrange it in arranged with two items, to be arranged with two items in each pair. That means to say you need to have two in a pair. Okay, so you have two, and here the order matters, because when you arrange the alphabets, let's take an example, like if you say inspire. Okay, when you say inspire, then here N has to come after I, and after N S has to come, then P. Okay, that means to say the order of the arrangements of the alphabets is very, very important here, right? The same way, when you take the alphabets here A, B, C, they want us to arrange it in such a way that you have two, okay, in a set. So how can we do that? So let us see applying the formula first, and then we'll see arranging it without applying the formula. So what does that say now? That means to say you have n is equal to 3. That is, number of different items is A, B, C. So 3 different items are there. So n is equal to 3 and r is equal to 2. How did I say that r is equal to 2? Because they want us to arrange this in pairs of 2, right? So r is 2. So that means to say NPR becomes 3P2, which is equal to 3 factorial divided by 3 minus 2 the whole factorial. What is 3 factorial? Let us see each one. 3 into 3 minus 1, that is 2 into 1. One factorial, which is equal to 1 always. 1 factorial is always equal to 1. So what does this mean? 6 ways. So how many ways you can arrange it in a particular order? 6 ways. Now let us see this in without applying the formula. Okay, so you have 3, right? A, B and C. So here you can take A and B together, A, B, one set. Then you can take A and C, okay, A and C. So A, C, A with B and A with C. Then B with C, B, C, okay. Then AB is different than BA, right? And CA and CB. As I told you, the order of arrangement here matters a lot. So AB is different from BA, right? So here permutations, particularly in permutation, the arrangement of the items or the objects is very, very important. So what is this comes up to 6 ways, right? Even while applying the formula also we say we got 6 ways. Here also 6 ways of arranging the objects. Now let us see one more example. Example 2. Here they've given the numbers, okay? This set consists of 1, 2, 3, and 4, okay? So here you can just see 1 with 2 makes one set, with 3, with 4. You have 3, okay? Then again, the reverse, okay? 2, 1, 3, 1, and 4, 1, okay? Then 2 with 3, 2 with 4, 2 with 1. That's what it comes in the reverse. And then 3 with 4, 3 with 2, and 3 with 1. Let's put it across and see. Okay. 1, 2, 1, 3, 1, 4, then 2, 3, 2, 4, then 3, 4, then you have 2, 1, 3, 1, 4, 1, 3, 2, 4, 2, and then 4, 3. So how many ways altogether? You have 12 ways. Let's see using the formula now. Npr formula. Here n is equal to how many different items you have? N is equal to 4. What are they? 1, 2, 3, and 4. There are 4 objects, 4 different objects, that is n. And r is equal to how many ways they have, how many in each set? You have 2. So npr is equal to 4p2, which is equal to 4 factorial divided by 4 minus 2, the whole factorial. What is that equal to? 4 into 4 minus 1, that is 3, into 2 into 1. What is 4 minus 2? That is 2 factorial, which is equal to 2 into 1. So what does this reduce to? 12, right? You can simplify and see that, okay? Yeah. Now let us see combinations. So far we have seen permutations. Now combinations. What does combination means? Here only the arrangement matters. The order of the arrangement does not matter. Okay. Let us see the definition. If we are interested only in arranging the objects and not in the order of arrangement. So here we are not interested in the order of arrangement. Okay, not interested in the order of arrangement. In other words, if we can put it across like this, the number of selections, the number of selections means to say combinations, okay, combinations of R items out of n different items is Ncr, which is given by Ncr is equal to n factorial divided by n minus r, the whole factorial, into r factorial. Okay, this is the formula for finding out the combination of the given particular set of objects. Okay, team 6 is equal to x comma z. Okay, now let us see this through the example of applying the formula Ncr is equal to n factorial divided by n minus r factorial into r factorial. What is n here? N different players, that is n is equal to 4, and how many in each team we have to arrange? 2 in a team. So 4c2 is equal to 4 factorial divided by 4 minus 2 factorial into 2 factorial. That's nothing but 4 into 3 into 2 into 1 divided by 2 factorial. 4 minus 2 is nothing but 2 factorial, 2 into 1, and here again 2 into 1. So what does this reduce to? 24 divided by 4, which is equal to 6 ways. So you have 6 combinations you can make. You can make 6 combinations of players, considering 2 in each team. Okay. Now let us see an example for combinations. Okay. We have 4 football players. 4 football players. Arrange them in teams, each containing 2. Okay, so let us see the solution for this. You have a set of a player set considering x, y, z and n. 4 players. Okay, now we have to form the teams. Let us see without applying the formula how we can do that. X, y, one team, then team 2, x with z, team 3, x with n, team 4, y with z, team 5, y with n. Okay, and then finally team 6, that is z with n. Okay, is that clear? So how many teams? 6 ways you can arrange. So there are 6 ways of arranging them in teams considering 2 players in a team. Here the order does not matter. Order is not important, because when you say here, say for example in team 1 you have x, y, okay, it is the same as y and x, right? When you say you have 2 members, you can say anybody's name in the beginning, and then later on you can say the other player's name, right? X, y is the same as y, x here. Okay, now let us see example 2 on combinations. Okay, the question says, in a society of 5 members, we have to select a committee a committee of 3 members as the owners of society. Okay. Now let us see the solution for this. Okay, solution. See, you have to observe here the word select I have underlined. Okay, I'll say about that now. See, how do you decide whether this problem is based on permutation or combination? Let us see that. See, you have a word select here. Okay, select means what? The order doesn't matter, right? Yeah, here that means to say we need to form a committee, okay, consisting of 3 members in each committee. That means to say it's a problem based on the combination. Okay, combination. Let us say you have for example x y. Okay, you have 2 members x and y. Okay, it doesn't matter whether we say x or xy or yx, right? You have 2 members x and y, and it doesn't matter whether we say x and y or y and x, both means the same. Okay, now let us consider the Ncr formula. Okay, what is Ncr equal to? Ncr equal to n factorial divided by n minus r, the whole factorial, into r factorial. Okay, what is n here? N is equal to the n different items. That means to say here in this problem it is 5 members. Okay, 5 members. So n is equal to 5. And r, okay, r in how many ways, how many members in each committee? It is 3. Okay, it's 3. So r is equal to 3. Okay, now so NCR becomes 5CR. Okay, 5CR, 5C3. Okay, r is 3 here. So 5 factorial divided by 5 minus 3 the whole factorial into 3 factorial, right? So now let us simplify that. 5 into 4 into 3 into 2 into 1. So whole thing divided by 5 minus 3 is 2. 2 factorial into 3 factorial. So what does that get reduced to? That's nothing but 10. Okay, you can simplify and see that it's 10. So there are 10 ways of combining the committee members and forming a committee. Okay, there are 10 ways or 10 combinations. You have 10 combinations. Okay, now let us see. You have some keywords, okay, for identifying whether the problem is based on combination or permutation. Now let us see first of all what are the keywords in the problems which based on combinations. Okay, combinations. The list of keywords here goes. It is select. Okay, as just now we saw a problem based on that, they would have given select certain items, okay, or choose some items or objects, or they would have said pick up some 3 or 4 items from out of 10 items, like that, or make a combination of 3 items out of 10 items, each considering of 3 in a set, or something of that kind. So these are the keywords: select, choose, pick, and combination. Then coming to permutation. Okay, permutation, you have keywords, that is arrange. They would have given it as arrange, or arranged, or arrange them based on, something of that kind. Okay, and then ordered ways, or order them, placed in an ordered way. Okay, like that they would have given. Or also they can give it as unique. How many unique ways of arranging this? They would have asked like this. So these keywords indicate that the problem is based on permutation. Okay. So let us say there are no keywords at all, any keywords which I have told you here. Then we can just think based on some common sense, which says, like, for example, members or players. Okay, wherever that is involved, using common sense, it says that the order doesn't matter. So in such cases, it is sure that it's a combination problem based on combination. So then you can directly go for the formula of combination. Okay. Subscribe and press the bell icon to learn more. Like if you are satisfied. Share to spread the knowledge. Write the doubts, if any, in the comments section. Thank you.